Hi, and welcome to our last discriminant video and our last systems of equation video. Now here are the three scenarios we've talked about before based on the discriminant. We're going to wrap up this series with one last tricky problem. So the graphs of y equal to 2x plus 5 and x squared plus y squared is equal to 9 has two intersection points. For what values of the gradient of the straight line graph will provide no intersection points? So very similar to last time, but quite different in some ways. We're changing the gradient and we don't want any intersection points. Right, here's our circle with a center at the origin and a radius of 3. And here's our straight line graph. And there are the two intersection points at the moment. But what we're doing this time is changing the gradient of the straight line graph. We're keeping the y-intercept at 5 and we're changing the gradient to get no intersection points, like that example there I've just shown you. All right, let's get into it. Let's write down the straight line graph, y equal to px plus 5. I've kept the y-intercept at 5 and I've changed my gradient to a number called p. Here's my circle formula, x squared plus y squared equal to 9, but I've substituted into the y px plus 5. Right, let's expand out the brackets. To do that, we've got to go px times px, which is p squared x squared, px times 5, which is 5px, px times another 5, which is 5px, and 5 times 5, which is 25. Right, we're going to simplify this. I'll show you what we've done here. A little bit tricky here, but be careful. These first two terms, I've factorized out the x squared. Now, I've put the x squared at the back of the brackets. That's okay. I'm allowed to do that. And I'm left with, inside the brackets, 1 plus p squared. And the 5px and 5px make 10px. Right, finally, I get to chuck the 9 onto the other side and make it a minus 9. 25 minus 9 leaves me with 16. So here's my quadratic equation, which is equal to 0. Right, well, this time we want no intersection points, and we need to look at the scenario number 3, where the discriminant is less than 0. So we're going to write down the discriminant, b squared minus 4ac, and put it less than 0. So let's carry on our working up here. Here's our next line of working. What have we done? We've put in the values of a, which is the number outside the x squared, which is 1 plus p squared. And I've chucked that inside brackets. We've put in the value of b, which is the number outside the x, which is 10p. And I've put that also in brackets because we're going to go b squared. And we've got c, which is 16. Right, 4 times 16 is 64, so we end up with minus 64 times the brackets. And I'm going to expand out the brackets. And now I'm going to go 100p squared minus that 64p squared leaves me with 36p squared, less than 64. And then I'm going to divide everything by 36. To get p squared has to be less than 1.78. Now I think it comes out to be exactly 1.7 recurring, but I've rounded it to 1.78 just to make it a little easier. Now at this stage, what I'm going to do is just put a hold on my working and work out what is the square root of 1.78. Well, that's 1.33 to 2 decimal places. 1.3 recurring is the correct answer. Now, let's have a visual look at what's just gone on. Here's my circle with two lines added. They both have a y-intercept of 5, but one of them's got a gradient of 1.33, positive, and one of them's got a gradient of negative 1.33, negative. But both of these lines actually touch that circle at one place, at one intersection. I want no intersection points. So what I need is all these gradients in here that won't touch the circle. And these are gradients that are between 1.33 and negative 1.33. So I can wrap this problem up and I can say the gradient for the straight line graph has to be less than 1.33. I'm not allowed to be exactly 1.33, or greater than negative 1.33. And for those who are a little bit observant, we would leave it in the recurring decimal form because that's the exact answer. So our gradient of our straight line graph has to be between negative 1.33 and positive 1.33 in order to have no intersection points. Cool, thanks very much for watching.